Okay, so now we're going to look at as a circle and an ellipse. So maybe you have, a circle like this, and then maybe the ellipse is, big like this, and it's around it. It's kind of an ellipse. And they don't intersect at all. No solution. Or maybe you have a circle. I'm going to draw a better ellipse this time. And it's like that, where they only intersect at one point. They're tangent to each other, so you get one solution. And then you could have a circle, and then maybe the ellipse goes like this. That's a better ellipse. Okay, and then you see there are two solutions. Maybe you have a circle, and the ellipse looks like something like this, where it's like tangent right here, but then there are these other 2 points of intersection, so there are 3 solutions. Or maybe you have a circle, and maybe the ellipse just intersects it with 4 solutions. 4 solutions. Okay, so those are some possibilities. Okay, now here we have a system of nonlinear equations. One is a circle, and the other is an ellipse. Now, how do you know the difference between a circle and an ellipse? With a circle, the coefficients are the same on the x squared and the y squared. With an ellipse, they're different. Okay, so, and they both have addition between the x squared and the y squared. So I'm not going to go over how to graph an ellipse. You might have had that in another class, and I'm not going to graph this problem. So we're going to solve it algebraically. Now, a little bit of review. Remember back on one of the other videos, I had a system of equations, and I was saying, oh, remember we solved this type of thing in the past? I think I had something like that. And remember we added the equations, and we said, oh, x plus x is 2x, but y and a negative y cancel out, so we eliminated the y variable. We call that process solving by elimination. And then you can solve this equation by dividing by 2. Anyway, that's a little review. We're going to use that same concept, though, with this system here. So see how I have an x squared, and here I have a 3x squared. So what I'm going to do is I'm going to take that top equation, and I'm going to multiply that equation by a negative 3. And that's going to give me the equation negative 3x squared minus 3y squared equals negative 78. Okay, then what I'm going to do is I'm just going to recopy the bottom equation. Now when you're using a system of equations, you always have to be careful to keep them straight, because you don't want to use the same equation twice in your solving. You don't want to duplicate it, then you're going to run into problems. But we'll just copy that bottom equation. And then we can add these together, and when we add them together, the x squared terms drop out. We get 22y squared equals, and then negative 78 and 100 is 22. So we looked out there. Divide both sides by 22, and we're going to get y squared equals 1. Okay, you can take the square root of both sides. That's going to give you y equals plus or minus the square root of 1, or y equals plus or minus 1. So you already have 2 solutions for y. Now you have to find x, okay? So it's probably easiest to use the top equation. You can use the other equation if you want to, but it's probably easier to use the top equation. I also have it written right here. So what I'm going to do is I'm going to take the positive 1 first. So I get x squared plus 1 squared equals 26. And then I'm going to solve this. So when I take the square root of both sides, I have x squared equals 25. I take the square root of both sides and I get x equals plus or minus the square root of 25, or x equals plus or minus 5. Now, here's something you have to realize. That was when we put in the positive 1. We used 1. 1. It's right there. That was the 1. And so what do we get? We get 1 matching with, oops, that was a y value, not an x value. So we get an x value of, I'll do the negative 1 first, negative 5, comma 1. Okay, because our y was 1 and we got negative 5, but we also got positive 5 and 1. So we have two solutions there, two ordered pairs, a negative 5, 1 and a positive 5, 1. Okay, so I'm hoping that makes sense to you. We plugged in a positive 1, so we were putting in 1 for y. So there's the 1 and there's the 1. But when we solved it, we got two solutions for x. So that's why there's two ordered pairs there. Okay, now we're going to use the negative 1. So I'm going to rewrite this equation right here. X squared plus y squared equals 26. But now I'm going to put in a negative 1 for y. And I get x squared plus 1 equals 26. Oh, it looks the same because we were squaring it, right? Okay, so you get x squared equals 25, or x equals plus or minus 5, right? You know, same process. So we're going to get two more ordered pairs for our solutions. What did we plug in? We plugged in negative 1 for y. And our x was negative 5. So you have an ordered pair negative 5, negative 1, and another ordered pair 5, negative 1. And so you get 4 ordered pairs for solutions. And you could graph this. I wasn't going to, but you could go to Desmos and graph this if you wanted to. But you get 4 ordered pairs for solutions on this problem.